Okay, so for this video, I'm going to give you one of the examples and how you're going to do it and to show you. So for number, I'm going to do number 1. So for number 1, we have f of x is equal to x cubed minus 3x squared. So in order to find our x-intercepts, we need to factor. So I'm going to take out what's in common. So here I have 3 x's, and here I have 2. So I'm going to factor out an x, and now I have x squared minus 3. To find your x-intercepts, you're going to set it equal to 0. So we have x is equal to 0, and x squared minus 3 is equal to 0. To keep going, we're going to now solve for x. So add 3 to both sides. We get x squared equals to 3, and then we take the square root. So our x-intercepts are 0 and plus or minus square root of 3. The next thing they ask us to find is our y-intercept. Well, to find our y-intercept, we equal to 0. So for my y-intercept, x is equal to 0. So I'm just going to plug that in. So f of 0 is equal to 0 cubed minus 3 times 0 squared. That gives me 0. So my y-intercept is 0, 0. The next thing I'm going to ask is if it's an odd or even degree function. Well, we look at the highest degree. So in this case, it's 3. So this is an odd function. The next thing is positive or negative. You look at the highest coefficient. In this case, it's 1. So we know it's going to be a positive graph. And now we're going to graph them. So using our x-intercepts, you're going to draw a coordinate plane. And then we know that my y-intercept is 0, 0. And my x-intercept is plus or minus square root of 3. Now we know it is an odd function, so we know that the ends are going to be facing different directions. And we know it's positive, so I'm just going to go just like this. Right here would be my relative minimum. And right here would be my relative maximum. And this is what you're going to do for each of the problems. All right, let's do example 2. So let's have it into the form of, let's do number 9. And we have 3x4 minus 3x cubed minus 3x squared plus 3x. So this one we're going to factor, but by grouping. So I'm going to take out here a 3x cubed, and I have left x minus 1. Here I'm going to take out a negative 3x. I'm going to have x minus 1 again. Now, I can factor it to 3x cubed minus 3x times x minus 1. And I'm going to equal it to 0. So, 3x cubed minus 3x equals 0. And x minus 1 is equal to 0. Adding 1, we have x is equal to 1. Here, I can factor out an x. And I have 3x, I can factor out a 3x. And then I'll have x minus 1. X squared minus 1 is equal to 0. This one keeps going. So now I'm going to do 3x equals 0. And x squared minus 1 equals 0. So divide that by 3. X is equal to 0. And add 1 to both sides. I get x squared equals to 1, and the square root of that. So x equals plus or minus 1. So my x-intercepts for this problem are 0, 1, and negative 1, and 1 again. This is what is called a double root, because it's repeating. All right. So now what we're going to do is we're going to find our y-intercept. So to find our y-intercept, we do f of 0. So I'm going to plug that in for all the x's. Cubed minus 3, 0 squared, plus 3 times 0. That gives me 0. So my y-intercept is 0, 0. Now I need to find if it's odd, even, or degree. So it's an even function. And it is a positive graph So when we graph it, we're going to have -1, 0, and 1. And since it's even, it's positive, both facing up. And then this is when we get the W going on. And then we have 2 relative minimums.
So blue that means.
Let me do one more example. Example 3. Number 5. I'm only going to show you how to find the x-intercepts on this one and the y-intercept. So you set each of them to 0. So you get x equals 1, x equals 3, and x equals 5. And then you find your y-intercepts. You do 0 minus 1, 0 minus 3, 0 minus 5. And that's going to give me -15. So my y-intercept is 0, -15. Here I have 1, 2, 3. So my degree is 3. And it's going to be a positive function. So when you graph it all you have to do is make a coordinate plane, and you get 1, 3, and 5. It's positive, so it's facing up and down because it's odd. And then you make the snake. Relative minimum is RM, and relative maximum.